What I'm going to do today is we are going to learn how to sketch the graph of a higher degree polynomial. So let's say that we have a function f of x equals, okay, now this is going to look a little crazy here, 3, then parenthesis, 3 times x plus 7 squared, then another parenthesis, x plus 2, close parenthesis, times x minus 3, close parenthesis, times x minus 5, close parenthesis, squared. Okay? This is what is called factor form of a polynomial. We've already seen this. For example, when we saw f of x is equal to x squared plus 2x minus 15, right? This is called standard form of a polynomial, okay? And it's a quadratic. It's a second power polynomial. It's of the form a x squared plus b x plus c, where c is negative 15, okay? And this is where we see the a, b, and c that goes with the quadratic formula, right? X equals negative b plus or minus square root of b squared minus 4ac over 2a, right? Okay? Well, as the power increases, as the degree of the polynomial increases, we have x to the third, then x to the second. So like what we might have here is, we might have ax to the third plus bx squared plus cx plus d. This is standard form of a third degree polynomial. You don't have to write this down. I'm just trying to get an idea in your mind. Okay? But note, haven't we also seen this as f of x equals x plus 5 times x minus 3? Haven't we seen that? Isn't this the same thing? All right? This is the same thing as this. But this is standard form, written as terms added and subtracted. This is called factor form, where you have these binomial things that are being multiplied. Okay? So this is factor form. Now, what is factor form useful for doing? Getting the roots, right? Getting the x-intercepts, right? Like we can take these individual, that's what you meant. Is that what you meant? Yeah, solving for x, right? If this is equal to 0, we know that if this whole thing, if we want to know the zeros of a function, which are the roots, that we know that if this equals 0, the whole thing equals 0. If this equals 0, the whole thing equals 0. Well, what will make this equal 0? Negative 5. That makes negative 5 a root, or an x-intercept. If 3 is equal to 0, then this whole thing equals 0. And so 3 is a root, or a 0, or an x-intercept, right? So that's the purpose of this right here. This is a polynomial in factored form. Morgan, I'll give you about maybe another minute on your laptop, and then if you can please wrap it up and set it aside. Thank you. Understood. So, this is factored form of a polynomial. What is the degree of this polynomial? What is it? So look, the power of this x is 2, right? Say it again. 6, right? See, what we do is we add up the power of each one of these. If this binomial is squared, this is the same thing as x squared plus 14x plus 49. That's an x squared element, an x squared factor, because the x is being squared. This x is the first power, this x is to the first power, this x is squared. So we have an x squared, this is an x squared, times an x to the first, times an x to the first, times an x squared. What x squared times x is x to the third. Times x is x to the fourth. Times x squared is x to the 6. So this is a 6th degree polynomial, right? Okay, so, but if we write it in factored form like this, we can easily identify the roots, the zeros, the x-intercepts, which we need in order to sketch the graph, right? Didn't we need the x-intercept to sketch the graph of a line? Didn't we need the x-intercepts to sketch the graph of a quadratic? Well, we need the roots of this polynomial to be able to sketch the graph. We need to identify the intercepts, okay? And so that's what we're going to do. We're actually going to sketch it right here, and I'm going to give you a procedure. Now, let me warn you. It is a long procedure. I have a total of 5 steps, and all of them, except the first one, have multiple lines of procedure, okay? So I want to be clear. I'm about to show you the procedure for sketching the graph of a higher degree polynomial, meaning degree higher than 2, and the procedure, to write out the procedure, is long. But I assure you, the actual procedure, once you start doing 2, 3, 4, 5, 6, 7 of them, they go really fast. You can do a whole one in less than a minute. Understand? So I'm asking you to please not get discouraged and say things like, oh my goodness, this is so long. Please don't do that, okay? Don't even do it in your mind. Be patient and trust that eventually, after you do a bunch of these, they're going to go by really fast. Get it? Okay, cool. Awesome. All right, so the first thing we're going to do in order to sketch the graph here is, let me start over here. Step 1 is you're going to plot the x-intercepts. Plot the x-intercepts. There is going to be an x-intercept generally for each one of these. Now, when you get to more difficult ones, which we probably won't get into in this class, one of these could be where it doesn't have a 0. I'm not going to get into that right now. Like if it's an x squared, if it says like x squared plus 7 on the inside, then it doesn't have a 0, but we're not getting into that right now. Okay? As long as you have a linear binomial inside of each one of these, it has a 0. Okay? So now here's what I want to know. What is the 0 of this factor? -7, right? So one of our x-intercepts is going to be -7, 0. Right? We're okay so far? That was easy, right? Okay? All right, cool. What's our next 0? -2. So we're going to plot -2, 0. Good. And 3 is the next one, right? Okay, good. So we're going to plot that right about here. 3, 0. Good. And 5. So we'll put that one right about here. All right, so step 1. Plot the x-intercepts. Okay. All right. Second, graph. Here's what you're going to do. You're going to graph what I call the limit of the function, the limit of f of x, as x approaches infinity. Okay? And I'm going to explain how to do that. Okay? So what side, and when I say side, I mean left side or right side of this graph, where is positive infinity? Where is x approaching positive? Where? It's the right side. So over here is where the graph is approaching positive infinity. Over on this side, the graph is approaching negative infinity. Why? Because if we keep going that way, what number are we getting closer to? It's not really a number, but what are we getting closer to? Infinity is over there, and negative infinity is over there. So when I say graph the part of the function where the limit of the function approaches infinity, I'm saying I want you to go over to the right side of the graph and do something, and draw a graph. You're going to draw something over here on the right side, okay? And here's what it's going to look like. It's going to look like one of two things, just one of two things. Either you're going to draw an arrow. Someone just asked me something? Okay. Arrow up, literally an arrow, like you're going to draw an arrow pointing up. Arrow up on the right side if the lead coefficient of the function is positive. I'm pretty sure we talked about this the other day. Okay? And what's the lead coefficient of this function? 3. And so that's a positive number, right? Okay? So over here on the right-hand side, watch what I'm going to do. Up on the upper side, in the first quadrant, I'm going to draw an up arrow. What I'm basically saying is that as this function, as the x values approach infinity, the output values are up and up. They're also approaching positive infinity. So as x approaches infinity, y approaches positive infinity as well. That's what that basically means, okay? Now, what if the lead coefficient was not positive? If it was negative, we're going to arrow down. Arrow down on the right side. On the right side. If LC, the lead coefficient, is negative. Now I'm going to show you what that would look like if that was the case in this particular problem. Okay? If the lead coefficient was negative in this problem, we would go down to the fourth quadrant down here and draw a down arrow. And that would indicate that as x is approaching positive infinity, y, the output values, are approaching negative infinity. Okay? We okay so far? Okay, cool. All right, good. All right, so that's step 2. Now let's move on to step 3. All right, step 3. Oh, I don't know that I left enough room for step 3. Well, let's just do it. I may get a little crunched up here. All right, step 3. Starting at the tail of the arrow. Starting at the tail. We're going to call it the tail of the arrow. Now note, this is an arrowhead. So this is the head of the arrow. So where would the tail of the arrow be? It's down here. That's the tail of the arrow. Starting there, you're going to put your pencil right there. Starting there, here's what you're going to do. You're going to draw the curve backwards. Oh, this should have been a comma. I'm sorry. Starting at the tail of the arrow, draw the curve backwards. Draw the curve, quote, backwards. Okay? Right to left, right, so the right side of the graph, backwards to the left side of the graph, right to left. Okay? Going through each of the x-intercepts. Going through each of the x-intercepts. Okay? Going through each of the x-intercepts. I'll make that one a colon, actually. And now I have two things to say here. When you approach each x-intercept, you have to make a choice. You're going to cross the x-axis at the x-intercept. Go ahead, say it. If the multiplicity, all right, let me explain multiplicity real quick. If the multiplicity of the root's factor is odd, of the root's factor, and I'll show you what the root's factor is in a second, is odd. All right? So you're going to cross the x-axis if the multiplicity of that root's factor is odd. Okay. This x-intercept, because if we're going backwards, the first one we're going to hit is 5, 0. This is the first x-intercept that we are going to deal with because we're starting at the tail and we're drawing the curve backwards from right to left, and we're going to go through each of the x-intercepts. Therefore, we're going to go through this one first, then we're going to go through this one, then we're going to go through this one, then we're going to go through that one last. Okay? All right. Now, so this 5, 0, the factor associated with this x-intercept is x minus 5, right? The multiplicity of a factor is the power of that factor. So what is the power of x minus 5? 2. And is that an even number or an odd number? It's even, okay? But this says go cross the x-axis if the multiplicity is odd. So is that true for this one? No. So there must be another thing we would do. Okay, well, the other option is this. There's only two options. Cross the x-axis if the multiplicity of the factor is odd, or, I don't know how to say this. Some people say the word bounce, but that winds up with weird-looking graphs of functions. So I call it touch and turn. Touch and turn. Okay? Touch and turn, comma, don't cross the x-axis. Don't cross the x-axis. Okay? If the multiplicity of the factor is even. If the multiplicity of the factor is even. Okay? Let me show you on an example here. Let's say that this is a coordinate plane. I want to show you what a touch and turn looks like. Okay? It's almost like an airplane is landing and then taking off again. It looks like this. Watch. So the graph is going to come in. It's just going to barely touch the x-axis, and then it's going to turn away. Do you see that? That's a touch and turn. It did not cross the x-axis. If it's coming from the bottom of the x-axis, it would look like this. It would touch and turn. Got it? Now can I show you what it doesn't look like? Okay, it doesn't look like this. Don't do what I'm about to do. So don't draw it, just listen. So some people, they say, oh, it bounces off the x-axis. And I'm like, okay, yeah, it bounces off the x-axis, which has in the past resulted in graphs that have looked like this. Because isn't that a picture of what a lot of people see in like a cartoon when a ball is bouncing, right? Don't do that. That's not what it looks like. It's not a sharp V, okay? It's a smooth U. And you are smooth. That was a terrible joke. Sorry. Puns are the joke of choice in my house. So every time there's an opportunity for a pun, I become drawn in. Okay, so we're going to touch and turn. Don't cross the x-axis, right? So let's go ahead and do this. I think I'm actually, my arrow is kind of angling over here, so I'm going to change it a little bit. So I'm going to come down. And what am I going to do at 5? Am I going to touch and turn, or am I going to cross? I'm going to touch and turn. So I'm going to go to this. Why? Because the multiplicity is even, right? So I'm going to come to this. I'm going to touch and turn. Do you see that? If you're not sure what to do at a touch and turn, just go to the point. Watch what you can do. You can actually, don't draw your arrow yet. You can go to the point and do this. You can make a little tiny U shape at it to make sure you get it right, and then connect. There we go. It's ugly, but it's correct. Okay? Now, where am I aiming next? This 3 right here. Don't I have to go there? Now we have a problem. We have a problem. This graph is turned away from the x-axis. So what am I going to have to do to get over here? Yeah, I need to turn it back. I need to make a hump. Okay? Like a camel's hump. Okay? So I'm going to have to turn it around again. See that? So I'm going to turn it around. And now what am I going to do at this 3?
Cross through it.
Cross. Why?
Because it's odd.
The multiplicity is odd. That's exactly right. So what does it look like to cross over the x-axis? Yeah? Bam, you're cutting through it. You're going to the other side of the x-axis. We okay so far? All right, now, where am I aiming now? I got to come over here. So I got to do a camel's hump, right? Oops, I went a little too far. A little too far. All right.
We don't learn the y-intercept.
Say again? We are, but we're going to do it last. We're going to do it last. Okay? So we are going to do the y-intercept, but we're doing it last. All right, what am I going to do when I get to this -2? Cross. Yeah, because multiplicity is 1. So we're going to cross through. There we go. And now what am I going to do when I get to this -7? Bounce, right? Or touch and turn, whatever you want to call it. So watch what I'm going to do. I'm going to do this one. I'm going to go over to it, and I'm above, right? I'm on the top side, correct? So I'm going to go over to the 7 on the top side. I'm going to make that little U shape. You see that? See how I did that? And now all I have to do is connect it. I'll make my camel's hump, and bam, I'm connected. Now I've touched and turned, or I bounced off, and now what am I going to do? I'm above. So let me write this down. You better write this down, okay? The curve finishes on the left. So dot, dot, dot. The curve finishes on the left. On the left. Okay? Pointing up or down. Pointing, not sideways, up or down. Pointing up or down. Now, do you think this one is going to be pointing up or down? Up, because it's on the top side of the x-axis, so it just points up, put an arrow, we're done. I mean, we're done with that part of it. We have 2 more steps. The fourth one actually isn't a step. So here's what I'm going to say. I want to talk about this, what's happening over here. Okay? So look. The left side arrow should point. Okay, here we go. The left side arrow should point dot dot the opposite direction. There's 2 possibilities. It should point the opposite direction of the right side. Yes. Yes. Of the right side. Oh, I'm sorry. No, that's same direction. If it's even. Yeah, aren't we pointing the same direction here? Right? But you get the idea. I mean, I was happy because I knew you got the idea. The opposite direction of the right side, meaning the right side is over here, pointing up or down, right? Back from step 2. So the left side should be pointing the opposite direction of the right side if the sum of multiplicities, okay, which we call the degree. So put degree in parentheses. If the sum of the multiplicities is odd. Now look at this. What is the sum of the multiplicities here?
6.
It's 6. 2 plus 1 is 3, plus 1 is 4, plus 2 is 5, or 6. So this is a 6th degree polynomial. And so it's the sum of its multiplicities, the degree is 6. Well, that's not odd, right? And that explains why the left side arrow is not pointing the opposite direction. Look, they're both pointing up. But if the degree of this was odd, this one would be pointing down. Okay? We doing okay? All right. The left side arrow should point the same direction direction as the right side if the degree is even. If degree is even. Okay? And in this case it is. It's even. So the left side arrow is pointing in the same direction as the right side. Here's what's going on here, folks. Let me show you what's going on here. The left side of the graph, okay, of the graph of the polynomial, there are only two choices. Sorry. It could be pointing up. Step two says that this side, the right side, is either pointing up, or it's pointing down. Those are the only two possibilities. Same thing with the left side. The left side can be pointing up or it can be pointing down. So how many possibilities are there? There's only 4 possibilities. Either both sides are pointing up, both sides are pointing down, or one of them's pointing up and the other one's pointing down. And there's 2 of those. We can be pointing up on the right and down on the left, or we can be pointing down on the right and up on the left. So there's only 4 possibilities. 1, 2, 3, 4. And I promise you that there is going to be a test or a question on the quiz or test that's going to give you one of these, and all it's going to say is which one of these is right. This, or this. And you got to be able to just glance at it and say, yep, I know. How do you know? Well, it's real easy. It's based on the lead coefficient and the degree. That's it. If the lead coefficient is positive, then the right side is up. And if the degree is odd, then the left side is the opposite of that, other direction. Okay? If the degree was even, bam. If the lead coefficient is negative, right side is down. And if the degree is odd, left side is up. If the degree is even, left side is down. How are we doing? We okay with this? All right, cool. All right. All right, last thing. Now, last thing we want to do is we want to identify the y-intercept, which is right here. Look, we want to label the y-intercept. 5. Label the y-intercept. Remember, to find the y-intercept, we just do f of 0. We just plug 0 in for x. That's it. Plug 0 in for x and get a number. So let's do that. You may need a calculator. Start with the lead coefficient. So we're going to do 3 times. If I put a 0 here, what do I get? 49, because 0 plus 7 is 7 squared 49. Did you guys understand that? Are we good? So you have to do these powers on them in order to get the y-intercept. So we've got 0 plus 7 squared, which is 49. If we put a 0 in here, what are we going to have? 2. If we put a 0 in here? Negative 3. If we put a 0 in here? So 0 minus 5 is negative 5. Negative 5 squared, negative 5 times negative 5 is positive 25. Now note, we got a positive, 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 negative, positive. So because we have an odd number of negatives, this is going to be a negative number. Okay? Now, you're probably going to have to do this in a calculator. And 50? Yep. It is. So 0 comes first. It's a y-intercept, so x is 0, then negative 22,050. There we go. All right, so 5 times x plus 6 times x minus 2 times x minus 7. All you have to do is draw a plus, a big plus on your page. That's your coordinate plane, and sketch. Go. I'll give you a couple minutes. So step 1, I'm going to plot the x-intercepts. So I got a negative 6. So let me tell you something I do, guys. I actually don't label my x-intercepts until I'm done because my curve sometimes winds up drawing through the label, right? Is it okay if I wait to label them? All right, we know that this is negative 6. Then we have 2 over here, and then we have 7 over here. Is that okay? All right, so I got negative 6, 2, and 7. Now I'm going to do my arrow. Is my arrow going to be pointing up on the right or down on the right? up because the lead coefficient is positive, right? So over on the right here, I'm going to draw an up arrow. Good. There we go. Now I'm going to go backwards here and thread through each of these intercepts. Either I'm going to cross over the x-axis for each one, either cross over or touch and turn. What am I going to do at 7? What's that? I'm going to cross through it because the multiplicity of x minus 7 is 1. Okay, so I'm going to cross through 7. Good. What am I going to do at 2? I'm going to cross through. So I got to do my I guess this isn't a camel hump. I guess this is a cup. Okay, I got to turn it around. Okay, there we go. Cross through. What am I going to do at negative 6? I'm going to cross through. So I got to make my camel hump here. And then I'm going to cross through and put a little arrow. Now I'm pointing down, right? Okay, I'm just naturally following it because it wound up on the bottom side of the x-axis. I'm going to go ahead and point it down. Okay. Now I want to try and figure out, is that appropriate? Are my two ends pointing in the same direction or opposite direction? Opposite, right? Is that appropriate? What is my degree? The lead coefficient is 5. What is the degree? What's that? Oh, odd. I'm so sorry. I take that back. Yes. Yes. It's odd because it's 3, right? 1, 2, 3. That's an odd number. Therefore, we're pointing in opposite directions, right? I'm going to go ahead and label this 7, 0. I'm going to go ahead and label this 2, 0. I'm going to go ahead and label this negative 6, 0. And now the only thing I have left to do is what? Yep. Label the y-intercept. So I got to do 5 times 6 times negative 2 times negative 7, right? Because they're all to the first power, right? All right, 5 times 6, 30, times negative 2, negative 60, times negative 7 is positive, what, 420? Does that sound good? Okay, so this is going to be 0, comma, 420, and I'm done. Was that a little faster than our first example? 4 times x minus 8. Go ahead. I'll give you a couple minutes on this. Do you see how this is a fourth power? We got a 2 and then a 1 and then a 1, right? And 2 plus 1 plus 1.
What do you do with the second power? Do you write that down twice? Or do you,
Let's see. Let's see. Do you mean what do I do with it when I'm doing what? This comes in 2 times. There are 2 times, well, really 3 times when this comes into play. The first time this comes into play is when we're drawing the graph, when we're choosing to whether cross over the x-axis or touch and turn or bounce off, whatever you want to call it, the x-axis, okay? This is telling us that at this particular x-intercept, we're not going to cross over the x-axis. Because this is even. This is called the multiplicity of the factor. So just to give you an idea, let's say we had a factor in a polynomial that said x. Yeah, so let's say we had x plus 5 to the 7th power. The multiplicity of x plus 5 is 7. When the multiplicity is odd, we cross over the x-axis. When the multiplicity is even, we do not cross over the x-axis. We do this. So here's negative 3, right? Negative 3, 0, okay? If we were coming from the top, which we won't be on this one, then we would approach the point and then go back the other way. Do you see how we're not crossing over here? That's called a bounce, a touch and turn, whatever you want to call it. So what I recommend is when you're drawing one of these, go to the point and just make like a little tiny U like that and then connect it. Huh?
kind of stay all on one line?
Correct. Or on one side of the axis. Okay? All right. All right, I'm going to go ahead and get started, y'all. I know you've already had a couple minutes to do this, so let's go ahead and draw it. I'm going to draw our ungridded coordinate plane. And we know we're going to plot negative 3, so I'm going to put that right about here. I guess. Then we're going to plot 4. I'll put that right about here. And then we're going to plot 8. Put that over here, okay? Now, the lead coefficient is negative. Therefore, the arrow is going to be pointing what direction? Down. Over here on the right-hand side, we're going to have an arrow pointing down. Everybody see where we are? We just finished step 2. Go ahead.
Why is it pointing down?
Because the lead coefficient is negative.
Oh, so when the lead coefficient is negative.
Then we're pointing down. But if the lead coefficient is positive, then we're pointing up on the right-hand side. And now I'm going to go to the tail of the arrow, and I'm going to start aiming for the x-intercepts. What am I going to do at 8? Am I going to cross over, or am I going to touch and turn? Cross over, because the multiplicity of x minus 8 is 1, which is an odd number. So we're going to cross over. There we go. Did I cross over? I did, right? Now I'm going to do the camel hump here, and I'm going to go towards 4. What am I going to do at 4? I'm going to cross over, because x minus 4 is to the first power. That's odd. I'm going to cross over. Good. All right. Now I'm going to aim. I'm going to do the turnaround. What am I going to do at -3? I'm going to touch and turn, because this is to the second power. That's even. So watch what I'm going to do. I'm going to go to the point, and I'm going to create. It's not a U. It's an upside down U. Do you see what I just did there? I made this little tiny frown right at -3. And now I can just sort of connect it. And now that I'm done, there aren't any more. So am I going to cross the x-axis anymore, or even touch it? Absolutely not. I am done. It's on the underside, so now I just need to point it. There we go. Yes?
I have a question. So you cross over 8 and 4 when you did kind of like a cross.
Yep.
Why did you cross it?
I crossed over because the power on the factor, what number is here? 1. And is that an even number or an odd number? It's odd, so I cross over. And isn't that the same for x minus 4? Okay, so I crossed over. Is it the same for x plus 3? No, so I don't cross over.
So it's not really like a added together type thing.
We're about to get to the added together thing. All right, now, so here's what we do. We add up all the degrees. What's the degree here? So Zarin, what's the degree? What's the power here? 2. What's the power here? And what's the power here? And 2 plus 1 plus 1 is? 4. That's an even number, right? Therefore, the two ends are going to be pointing in the same direction. Are we good? We good? Okay. All right. Now we're going to do the y-intercept. Now watch this. This is the third time that comes into play. To find the y-intercept, we're going to multiply the lead coefficient times, we're going to plug a 0 in here. What's 0 plus 3? 3 squared. 9. See, we have to take this and then square it. 9. Then this one is 0 minus 4. It's -4 to the first power, so that's just -4. And this is -8 to the first power, which is just -8. If we were to multiply this, we would get -4 times -2. That's +8. +8 times -8 is -64. And -64 times 9 is like -500 and something. 576. Okay, so 0, -576. And I'm done. And if I were to key this whole thing into Desmos, I would get something that looks very similar to this. Okay, we ready for another one? Okay. All right. All right. Let's do, how about this one? Let's do negative parenthesis. Do you guys know what's happening here when I put a negative and then open the parenthesis? What's the lead coefficient? It's -1. That's right. So then we're going to do x plus 7 squared times x plus 2 times x minus 5 squared. All right, go for it. So what is the degree of this particular polynomial? I'm going to start. So our x-intercepts are -7, -2, and 5. We have a negative lead coefficient, so our arrow is going to be down on the right-hand side. 5, the factor associated with the intercept 5 has a power of 2, multiplicity of 2. So I know that I'm going to turn around there, so I'm going to make a little U and connect it. Am I okay so far? Yeah. All right. So then I know at -2 the multiplicity is 1, so I know I'm going to cross over at -2. That wasn't very good, but there if you just make the dot bigger, it's fine. Okay? And then I know that I'm going to turn around. I'm going to touch and turn at -7, so I'm going to go, but I'm above. I'm above here, so I'm going to do this. I'm going to connect it, and then I'm going to arrow up. How's it look? Does it look very similar to what you have? Yep. And 2 plus 1 plus 2 is 5. So that's odd. So the degree of this whole polynomial is 5. And that's why one side is pointing down and one side is pointing up. And the right side is pointing down because the lead coefficient is negative, right? And now we just need the y-intercept. Let me go ahead and label these. I got 5, 0. I've got -2, 0. And I've got -7, 0. And then I'm going to put a 0 in here. Now note, I got to put this negative on the front of this whole multiplication. Got it? You could even put a -1 in. It might be a good idea for you to put a -1 in parentheses to represent the lead coefficient. Then 0 plus 7 is 7. 7 squared is 49. 0 plus 2 is 2. 0 minus 5, -5 squared is positive 25. Okay? And so 25 times 2 is 50. 50 times 49, what is that? 2,500 minus 50, so 2,450. Okay? But it's negative because we got to multiply it by -1, so 0, -2,450, and we're done. I think we should do one more. Let's do one more. Okay? Let's do, we'll put a 4 at the front, positive 4 at the front, and then let's do x plus 3 times x minus 4 squared. Do that. Should be able to do this one like maybe a minute, minute and a half by now. Okay, so I'm going to go ahead and start. We've got zeros at -3 and +4. So that's here, maybe over here. Lead coefficient is positive, so we're arrow up. Drawing backwards, at the 4, we have x minus 4 squared. Multiplicity is 2, so we're going to do the touch and turn thing. There we go. And we're going to do a camel hump here. And then what's that? We're going to go through -3. That's right. Bam. A little ugly, but you know what? It does the trick. It turns out my arrows are pointing in the opposite direction. Is that appropriate? I got a degree of 1 here and a degree of 2. Add them together, get a degree of 3. So appropriate, right? Odd. Okay. We're going to label this one as -3, 0. We're going to label this one as 4, 0. Now we just got to label the y-intercept. What'd you get? 192. Sounds like it could be right. 3. This is 0 minus 4. It's -4, but it's squared. That makes it a positive 16. 16 times 4 is 64. 64 times 3 is, say it again, 192. So we got 0, 192, and we have a graph, and it works. We doing okay? Awesome. Okay.